Hello and welcome to Maths with Raz. I'm your host, Mr. Raz, and today we'll be looking at integration of the area under a curve. So you'll have seen the other two videos where you introduced integration. What happens now is that we see the full, well, not the full use, but we see the main use of it, which is we have a curve finding the area underneath it. Yeah, so what is important to realise is that these things here we call limits, and they correspond to that bit of the integral. So if I'm reading this integral here, it says integrate the function y with respect to x between the limits of a and b. Yeah, and so I'm just going to go straight into a worked example, and hopefully you'll be able to follow what's going on. Let's clear that screen. All right. So there's a question. So hopefully you'd be able to integrate that normally. So forget the limits. And if you've watched the other videos, you'd realise that we get this. X4 plus x plus c. Now, I'll explain why in about 2 minutes. But what we do is we sub the upper limit into the function. And we sub the lower limit into the function. And we subtract the answers. Yeah. And that will give us the answer to, that will answer the question for us that and give us the area that we're trying to find. Doing that, we would get 76/4. Now, hopefully, you're noticing here that this C there and this C will cancel, that's right. Because you can see C minus C is 0. So whenever we're using limits, there's no need to worry about the constant of integration because it will always cancel out. Now, this is the science bit. X cubed plus 1, well, wouldn't look like that. That's a graph of x cubed, but the principle's the same. We would find, if we subbed in the value of 3, we would get this purple area here. If we subbed in the area of the value of 1, we would get that area. So if we subtract those two, we get this little strip here. Now that is the answer that is the area that we actually want in the question. See, we want the area of that function between the limits of 3 and 1. And that, so by doing that subtraction, we get what we're looking for. And that is why we do the upper limit minus the lower limit. Yeah? So, can you pause the video now and give this a go? Welcome back. Now, so we have, first we integrate. So first we integrate, and we get, let's get a thinner pen in there, and we end up with 4x to the 4/4, x to the 4 plus 9x. Now, when we've integrated, we put these square brackets in. That means we have just integrated. And we put, to say that we're going to sub between the limits of 3 and 0, we put those there. And then we do it. So I put the bigger number in first. So that's 3 to the power 4 plus 9 times 3 minus 0 to the power 4 and 9 times 0. Well, that is 0. This is 81, that is 27. So we end up with 108 minus 0, which is 108 units squared. Yeah, so you can see we integrate as usual. Square brackets represent, say that we have integrated. and between limits of 3 and 0. Well done if you got that one. Right, give that one a go, please. Again, pause video. Welcome back. So we integrate that, we get x squared over 2 plus 4x. Again, we don't need to worry about constant integration because it will cancel. So we have 3 squared over 2 plus 4 times 3 minus 1 squared over 2 plus 4 times minus 1. Dun, dun, dun. So that is 9 over 2, let's go 4.5, that is 12, this is plus a half, and this is minus 4. So this whole amount will be minus 3.5, and this whole amount will be 16.5. So the answer is 16.5 minus 3.5, which is 20 units squared. Hopefully you all got that. If not, then obviously rewind the video and go through it. Now, to extend our knowledge a little bit with this question, find the area of the shaded region. So hopefully you realise that you need to integrate the function x cubed plus 7 with respect to x between the limits of 5 and 2. Yeah. Pause video and go. And welcome back. So again, this gives us x to the 4 over 4. Let me just partition that. Plus 7x between the limits of 5 and 2. So we will have 5 to the power 4 over 4 plus 7 times 5 minus 2 to the power 4 over 4 plus 7 times 2. Again, I'll neaten this up a bit. So what's that? 625, 5 cubed is 125 times that by 5, 65 over 4 plus 35. Well, let me just go back to that one because that ain't going to make it nice, is it? 65 over 4 plus 35. Well, 35 in quarters would be 140. Minus 16, 2 to the power 4, 16, divided by 4 is 4, plus 14. Yeah? So we have 765 minus 18. Well, that's 72 over 4. So 693 over 4 would be the answer. Yeah, units squared. So when we integrate in between limits, that's what we're doing. So that's obviously another way for them to ask the question. This was to say, find the area of the shaded region. And if so, that is how you would attempt it. Can't remember what's on this next slide. Yeah, all right. So last one. Again, if I ask you to find the area of the shaded region, this time I'm expecting you to figure out the limits. So hopefully you can see that these limits occur when y equals 0. So if we set this equal to 0, it will follow that x equals 0 and x equals positive 9. So we need to integrate that function 9x minus x squared with respect to x between 9 and 0. Integrating, we will get 9x squared over 2 minus x cubed over 3 between roots of 9 and 0, which will be 9 times 81 over 2 minus 9 cubed over 3 minus 0. Yep. So if you type, you can just type that into your calculators probably. What I'm doing. 9 times 81 over 2 minus 9 cubed over 3, blah, 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 243 over 2 units squared, which is 121.5 units squared. Yes, so that is just a little bit of an additional step onto the last example, where here we had to just figure out the limits. Yes, the limits, we were integrate between under the curve on the x-axis. Yeah, so we had to set y equals 0 to figure out what those limits were. And that's all for this video. Join me in the next video for integration, the area between a curve and a line. Thank you, and I'll see you soon.